Okay, let's do the first one. Any idea how to do this one? Some people would just say, okay, since the green field is much simpler, just use green field and do the same result, right? Actually, let's see how simple a green field is comparing to just evaluate this line integral directly. Okay, remember the circle here means the line integral is calculated over a positive orientated curve. Okay. Okay. So how does let's draw the triangle, right? The vertices. So it goes from 0, 0 to 1, 0 to this one, go this way, and then to 1, 4, and then go back to 0, 0. So this is the boundary of this region inside that region D. Okay. Okay. Now, if I calculate this line integral directly, then we need to parameterize the 3 line segments. This one, and this one. Okay. And let's call this one, well, it's like a good review for you. So let's call this C1. And let's call this C2. Okay, can you guys see? And then this is C3. Okay, that one. Okay. Let's parameterize C1. C1 is, what is it? Well, the y here will be equal to 0. So that's easy. So just put y equal to 0. But x equal to, x is equal to x, right? But since for others, we use others, how about we use t? Yeah, we can put x equal to x, but we can also put x equal to t, okay? So x equal to t. Okay. And the t over here go from what? Go from 0 and to what? 1. Yeah, you got it. It's 0 and 1. So this is a parameterizing this line segment over here. Okay. Okay, let's do the second one. Okay, so that one, the x coordinate is a constant, right? They stay as 1, so x equal to 1. That was an easy one. And then what about y? Y go from 0 to 4, right? Okay, we can put y equal to y. However, let's use a parameter. Okay, let's call it t. Okay, so that's equal to t. T go from what to what? 0 to 4. Yes, you got it. Okay, and C3, that one. So how do we parameterize this? Is it this way, right? It go from here to here. It started here, right? You started here and ended here. Do you guys remember how we did remember last time we said to parameterize the line segment, that will equal to what? 1 minus t times r0 plus what? T times r1, right? Yeah. So in this case, what is this r0? You starting here, right? You started over here. That's the starting point, okay? And that one is 1, 4, okay? And what's R1? This is the ending one. So you end it over here, right? 0, 0. So that is 0, 0. So that is 0, 0. So you will get, this is just 1 minus, this 1 minus t times this. Okay. So that is just 1 minus t times. To do this, so x is, what is x? X is equal to 1 minus t times 1, right? Which is just 1 minus t. Okay, 1 minus t, and then the second one is 4 times 1 minus t. So x is equal 1 minus t. Okay, y is equal to 4 times 1 minus t, right? So you see how tedious is it? Okay, t go from what to what? t go from 0 to 1, right? Remember when we parameterize this right here? T go from 0 to 1. Okay, it's good. Okay, now for this one, we need to find, in order to find this integral right here, in order to find this integral, you need to find, okay, so we have x and y parameterized, and then you put dx over here. You need to find out what dx here is, right? You have the dx here. So from this, what dx is equal to dt.
Okay.
Yeah, dt. Dx equal dt, right? Okay. And what's dy? Differentiate 0, you get what? Y equals 0. What's dy? It's a 0. It's a 0, right? dy is a 0. Okay. Or 0 dt or 0. Okay. So 0 dt, which is 0. Okay. Okay. Now what about the second one? What's dx? Dx is 0, right? And then dy is dt, right? Okay. And then this one, dx is negative dt, right? dy is what? Is it negative 4 dt, right? Negative 4 dt, okay? Well, you see that it's already more complicated than the Green's theorem, okay? Then after this, how do you find that integral? Okay, let's do that. Okay, let's just do the first, just do it once, and then you will appreciate Green's theorem a little bit. Okay, let me just copy it, okay? So we are trying to find this integral of xy, c dx plus x squared y cubed dy. So what does it equal to? Then now we just need to make it into three integrals, right? Three integrals. The first one will be over c1, right? And then here c2 is c3, and we sum them up, right? So I actually omit writing the things right here. Okay. Okay. So the first one is over c1. Then you need to find this x times y. What's x times y here?
0.
It's 0, right? So you get the 0. And x squared y cubed will also be with x squared y cubed. When y equals 0, both this one and this one will be equal to 0. So that integral here is a 0, right? Or it's an integral of 0, right? Integral of 0. And then dt. Okay. And t go from 0 to 1. Okay. And then plus the second one. Okay. The second one over here, okay, integrate over c2. So x times y will be t, but then it's going to be dx. But what happened to dx? Dx is 0. So that will become 0, that part. This part here will become 0. What about this part? This part here will be x squared times y cubed, which is t cubed, right? So you get t cubed. And what's dy? Dy is what? dt. So that will be t cubed dt. Okay, so we have t cubed dt here. T go from 0 to 4. Okay. And right now it doesn't look too bad, but okay. Plus, and the last one here is what? Okay, now it's about C3. Okay, for C3, okay, let's think about x times y will be this times this, right? Okay, so that times that is, and then dx. So you will have 1 minus t times 4 times 1 minus t, and then the dx here is negative t. Okay, so negative t right there. And then t go from 0 to 1. That's for this part. But then for this part over here, you have, for that part right here, let's see what do we have. X squared y cubed. So we have x squared, which is 1 minus t squared. Y cubed is 4 times 1 minus t, and then this cube. And dy over here, dy here is negative 4 dt. You already say 4 dt. Okay, t go from 0 to 1. Now you already see that it's very tedious, right? Now, at the end, you come up with this answer. Now, what about if you, okay, so I'm not going to continue, but this result should be the same result as you use green theme. You can verify that. Now let's see how do we use green theme to do this integral. Okay, let me copy that one down. If I use green theme, let's use a green color to do that one. The integral x1 dx plus x squared 1 cubed dy. Okay. Now using green theme, what does this say? This single integral, remember this is over the boundary, right? Okay. That's equal to a double integral of the region. Okay. So double integral of the region, let's call that region D. And what should I put over here? If I remember, possibility of what? With respect to x. And okay, let me put this thing. Minus possibility of what?
P to 1.
With respect to y. Okay. And here dA. Okay. So this one here, you put this function, this cube. Okay. X squared y cubed is the one. So you take this one. This is x squared y cubed. And minus the possibility of this. This is the p. Remember, this is the p. And this is the cube. So this is xy. Okay. Like that. So it's already much simpler. And that region, the region over here, notice the region that we have over here. It is, you can consider this as a type 1 or type 2 region, right? Which one you like? You want it to be type 1, right? So if it's type 1, you will find the upper one, the y over here above. Y is equal to what? The slope, what's the slope of this? 4, right? 4x. And then down here, the y here will be equal to 0, right? So above one here is y equal to 4x. Then the below one here is y equal to 0. Okay. So you can, when you draw this, so y will go from 0 to 4x, right there. So then you will turn this into this integral, whatever you got here. So you have dy dx. Y will go from 0 to 4x. And what does x go from? X go from where to where? 0 to 1. Yes, you got it. Okay. So x will go from 0 to 1. Yeah? So it's much simpler to use green theme right here. Okay? Okay, so that was the first one. And now you already appreciate green theme more. Because the amount of work that, even for a simple triangle like this, then it's already very tedious, right? And however you use green theme, the process is much simpler. Okay, now let's do number 2. Okay. Use green theme to evaluate this integral along this given positively oriented. Let's draw the curve and see, get a feel of how it looks like. If you're looking at this curve, x squared plus y squared equal to 16. That is a circle with radius, with radius equal to 4, right? So it's the positively oriented, so it has to be counterclockwise like that. Okay. So looking at the shape of the curve, we know that we want to use polar coordinate later on, right? Okay. So how do we find this integral? That integral over here, this is the integral over the boundary of this curve, right? So according to green theme, is equal to double integral over the region. Let's call that region inside. Let's call that D. E here. And what should I put in here? Inside this double integral. Partial derivative with respect to x minus partial derivative with respect to y. Okay, and then dA, right? This is supposed to be q, right? What is q?
Negative 2.
Q is this is q, right? Okay, and p is this one. This is a p, right? Okay. And then you just continue. And when you do that at the after you take partial derivative, because the region is circular like this, so you think about using polar coordinate, right? So at the then you express this as r drd theta. Okay. R go from what to what? R go from
0 to 4.
0 to 4. You got it. Good job. Okay, 0 to 4. And then theta go from what to what?
0 to 5.
0 to 2
2
pi.
pi.
Yes, you got it. Good job. Okay. 0 to 2 pi. Perfect. Okay. All right. So that's how you do it, right? Not too bad. Green theorem, right? Okay, the next one. Use green theorem to evaluate this integral. The F here, think about that like a what do you call that? Vector field, right? Vector field, kind of like vector field, okay? And then over this curve C. So they give you this vector field right here, okay? F of xy equal to this. And then they give you the curve C. The curve C here is a triangle. So I draw it over here next to it, okay? So what do we do over here? Okay, so let's write it down. So this integral of this, and remember this is a dot product, okay? Dotted with dr over this curve C, that's equal to, let's just write it down, write it down. Okay, F here is, the first component over here, this is a P, okay? And this is the Q. This is a Q. This is a P, this is a Q. So you will have this P over here, dx plus Q dy, okay, over C. Actually, look at the orientation. There's a hint. Okay, check the orientation of the curve before applying the thing. Because green theorem says that it has to be positive orientated in order to convert that relate to the double integral, right? So this C here, do you think it is positive orientated?
Negative.
No, it is negative orientated, right? So what should I do to turn this into positive orientated? We take the opposite of it, right? So if we take opposite of this, so this one here it is negatively orientated. So to do that, so in order to apply green theorem, you take the opposite of it. Okay? So opposite of C, and then P. But if you change this to opposite of C, what should I put in front? Remember we talked about line integral? You just need to put the negative sign in front. Okay? So you put the negative in front. So that this will cancel out with that. Now what happened here? The goal here is this. It is positively orientated. Apply green theorem, you have to have this to be positive orientated. After that, what should we do? That's equal to, so the negative sign here, this single integral over this boundary curve, okay, over this curve negative C, that will turn into a double integral, right? According to green theorem, double integral of over this region D. What's that region D? The region is inside here. This is D. Okay. So the region D right here is D inside. And what do we have inside? What should I put? Possibility of what?
Q.
Q. Yes. Possibility of Q with respect to what?
X.
X. Got it. And then plus or minus?
Minus.
Yes, minus what? possibility
derivative
of
T
P
with respect to Y.
with respect to Y. Okay, and then here dA. This one you certainly, this is a type, you can think about it as a type 1 region. Okay? It's not circular, so you don't want to use a polar coordinate. You can just take care of that, right? So, yeah, so then that's how you do it. So if the orientation of the curve is not positively orientated, you, in order to apply Greenfield, you will put a negative sign, put the opposite of the curve like that, and put a negative sign in front of the integral. Then apply Greenfield to this integral that has the curve to be positively oriented like that. Okay? And now you know what to do afterward, right? Okay, good. All right, the last one. Okay, ask someone to read this. How about Raymond? Could you read this? This.
Use these students to find the work done by the force F of x, y are equal to x of parenthesis x plus y parenthesis I plus x and y square j in moving a particle from the origin along the x-axis to 1, 0, then along the line z aligning to 1, 0, 1, and then back to the origin along the y-axis.
Okay, very good. Thank you. Okay, so do you guys remember how do you calculate the work done by a force right here? What is it? Can you remember?
Do you get the direction vector first?
Yeah, the work done by this force, right? So the work done by this force, okay, let's call it W, okay? So W for work is the integral, okay, integral of the force, and then what?
dr.
Dotted with dr. Wow, you guys learned a lot. You guys been very good at it. Okay. Okay, and over the curve C, right? So over the curve C. Okay. So that will, that's how we talk about that integral. We talk about the work done by the force. Okay. Along the curve is the dot product of this. The integral of this. So what is this one over here? That's equal to curve C. Like this. Remember, we want to. Well, remember this 9 integral is actually this is actually the 9 integral. Okay, so f is equal to this dr. Okay. The dr here. This is actually the same as, remember this is the same as the p dx plus q dy, okay, of the curve, right? It's the same as, okay? Okay, so the p over here is what? What's p? P is, the P over here is this, right? This is the P. Okay, what's the Q? The Q over here is this one, right? This is Q. Okay. So this curve C, is it positive orientated?
Yes.
Yeah, it is, right? It's a counterclockwise like that. And then we know the P, we know the Q. Now we can just use Greenstein to do it, right? Okay, so we use Greenstein to do that. So that will be the double integral over this region. That region is what? It's called a D, dy there. And let's write the formula one more time so that we can remember, right? This one will be what? Positivity of Q with respect to x. Okay, subtracting
Partial T.
possibility of P with respect to
Y.
Y. Yes, good job. Okay, PA. Now for this region, you want to think about this as the type 1 region, right? So if you have the type 1 region, so if you draw a nice segment like this, so the Y go from what? Y go from 0 and then to, what's the equation
Oh.
for this line? 1 equal to,
Is it negative?
is it 1 minus x? Yeah, it's negative. Yes, the same as negative x plus 1, right? It's negative x plus 1. So after that, you can just write this integral and here whatever you have. So dy dx. Okay, y go from 0 to 1 minus x, and then x go from what to
1.
0 to 1. You got it. Okay, so it's going to be from 0 to 1. So over here and 1, and then we're done. Okay, so remember this. So that's how you do this.